The encountered wave period. Say we have a vessel over here with a speed of, well, vessel speed is approximately 16 knots, so Vs is 16 knots. Okay, then we have a alpha of 60 degrees. Well, the alpha is the angle between the keel and the direction of the keel, the course, and where the waves come from. So that will be something like this, alpha. So perpendicular to it we have the wave crests here and say there. So this will be the length of the wave, sometimes called lambda. What we know is that the time of the wave, so the time of the wave, so the time between the wave crests is something like 11 seconds. Okay. So what we like to calculate is the encountered wave period. So from this we would like TE equals something. Okay. Well, first look at the formula of the encountered wave period. TE is defined as the length of the wave divided by speed of the wave added by speed of the ship times the cosine of the angle alpha. So first thing we would like to do is what is the speed of the wave? Well, have a look at this one. You can say speed of the wave with a v velocity, or c, we talk about celerity, is defined as 1.56 times the period. Well, the period of the wave we happen to know, so that is 1.56 times 11 seconds gives us something like 17.16 meters per second, or a 34.3 knots, something like that. We'll stay in a metric system over here. So the length of the wave would be something like the speed of the wave times the period of the wave. Oh, that would be 1.56 times wave period squared, and in this case that will be something like 188.76 meters. So let's fill in the encountered period. So TE would be something like 188.76. So this is OEW. See, we have a wave speed of 17.16 added by the 16 knots, that would be 8 meters per second, times the cosine of 60, and that equals some 8.9 seconds. So that's an interesting one. If the encountered wave period equals more or less the heave period, the natural heave period, or the natural roll period, or the natural pitch period, you can get some resonance. Okay. When we look at the graphs of the natural heave period, we have the degrees over here. So we have the alpha angle. Say this is a 0. We have a 90 degrees and a 180 degrees. So here we have the encountered wave period. So we could say that graphs normally look like something like this. And there's another one coming in from there, going that way, or even something like this. So this is the different ship speeds, say 8, 12 and 16 knots. So speed is going up, and you can look for your desired or not desired encountered wave period. So if you have a heave period, say So this is your natural heave period, T heave. You can look for, well, this is probably not the angle I would like to have on my course. So on your calculator, see how it works. And put a calculator over here. Put it on. See if it works. Put it on. Yeah, there it is. We go to mode, check if we're in degrees. No, we're in radians. So we go to Y. So let's define the encountered wave period. I take 108. You should put in decimals, but I will not do it here. Divided by 17.2 added by, well, in our case it's a speed of 8 meters per second times the cosine of the angle top. So I put another one. That's 188 divided, it's the same thing except for the speed of the vessel, 17.2 added by, well, let's not take an 8 but a 6 something, 6 times cosine of alpha. Now we have to get our window right. So the x is the alpha, so it runs from 0 to 180 in steps of, say, 10 degrees. And this would be something from 0 to, well, say a 30 knots relative steps of 5. Well, see how the graph looks. There it is, going up. Yes, something we expected over here. There's the other one, it's very close. So it's not so much discrimination over here. So what we could do is make a few of these graphs. And then you say, if I have a natural heave period of, say, a 9.3 seconds, you can plot that as well. There it is. And now you could zoom in and find out where, at what alpha, we have an intersection. So first, redefine your window. See, we can say we take 100 over here. And from 0 to a 20. Maybe that gives a better view. This takes a while. That's the first one, 8 knots. There's the intersection, and there's the angle. Well, so we say second calc intersect. We go here, and we say first curve. Yes, that's the first one. No. Oh, we didn't do it right. Enter, it's calculating the angle of the two curves. Well, that will probably be 90 degrees. That's what we expected. But what we should do is second calc, go to intersect. There we are. First curve is all right. Yes, that's the 8 meters per second, 60 knots. And the second one, no, it's not right. We would like that one, 9.3 natural heave period. And I guess we go to the left, somewhere here, and you say, okay, and then we find an angle of, say, 68 degrees. So you know that at 68 degrees, you have a natural heave period more or less equal to the encountered wave period. Something you should avoid. Okay, thanks for watching.